everyone, and welcome to another math tutorial. The second video in chapter 2 on matrices is titled Matrix Multiplication. And all we're going to simply learn in this video is how to multiply a matrix times another matrix. Let's jump right into the rule, and then we'll see some example problems. So as I just stated on the title slide, matrix multiplication is multiplying a matrix by another matrix. So in the last video we did scalar multiplication, which is different than matrix multiplication. Now when you do matrix multiplication, the sizes of the two matrices that you're multiplying matters in a very specific way. It's something that you have to check every single problem. And so I want to explain what you can and can't do right here. So let's say we have two matrices, matrix A and matrix B. And matrix A has a size m by n. So m rows and n columns. Matrix B has n rows and r columns. That's its size. Here's what you have to check for. Okay? The number of columns of matrix A and the number of rows in matrix B must match. Okay? If those numbers don't match, then you cannot do the problem. Okay? If they do match, you can proceed. And the leftover dimensions, which are in this case the m and the r, those numbers make up the dimensions of your product, of your solution. So if you multiply those two matrices together, matrix AB is going to have dimensions m by r. Okay? So the outer dimensions here are going to make up the dimensions of your product. But again, you can only do this if the inside dimensions, or I sometimes call the inner dimensions, match. If they don't match, then you just don't even start the problem. You just say it has no solution. All right, let's jump into the first example problem. Okay, the first example problem, and actually all the example problems are just going to ask us to find the product of the matrix. So the first thing I always do is you want to check the size of the matrices. And I'm just going to write that right below. So this first matrix has 2 rows and 2 columns. So this is a 2 by 2 matrix. And the other matrix also has 2 rows and 2 columns. So it is a 2 by 2 matrix. And again, what you're looking for are these two numbers to match. Okay? If they do match, in this case they do, then you simply take those out, and what's left are the dimensions of your answer. Okay? So our answer is going to have 2 rows and 2 columns. Okay? So let's go ahead and set that up. I want a matrix that has 2 rows and 2 columns. Now, for the sake of my work, I'm going to be a little bit annotative in this first example, maybe the first couple examples, to kind of illustrate how to do this. Since we have canceled out the column number here, we've kept the row number, what we're going to do in this matrix on the left, we're going to use just the rows. Okay? I'm going to go ahead and label those. We're going to use this row, I'm going to call that row 1, and this row, call it row 2. And in the other matrix, we've canceled out the rows and we've kept the columns. So I'm going to label the columns. This is column number 1. This is column number 2. And I'm going to go ahead, just to keep it clear exactly where we're looking, I'm going to highlight these things for us in this problem. So we're going to use these rows, and we're going to use these columns. Okay? Very important that you use the numbers this way, in this manner. All right? Now, on my answer matrix, this answer matrix has, just like over here, we've got rows. There's going to be 2 of them, and columns. There's going to be 2 of those. So I'm going to start with this entry right here. Okay, I'm going to start for the entry that's in the first row and the first column. And I'm going to do that work down below here. I'm going to do that scratch work down here. So I'm going to look for row 1, column 1's entry. Here's how I find it. I'm going to take row 1, I'm going to take the 2 and the 5, I'm going to take column 1, which is the 4 and the 6. What I'm going to do is I'm going to multiply the first number of each row and column. I'm going to multiply 2 and 4 together. I'm going to add to that the product of the second number in each row and column. So I'm going to multiply 5 and 6 together. I'm going to go ahead and do those products. So I have 8 and 30, which is 38. That's the first number up here. All right. Now I'm going to stay in the top row, but I'm going to work with column 2. So now I'm going to do the work down here for row 1, column 2. Okay. So we're going to stay right up here in the top. I'm going to keep using 2 and 5, but this time I'm going to use -3 and -2. So the first number, 2, gets multiplied by the first number, -3. And then I'm going to take the second number, 5, times the second number, -2. Now let's work that out. I've got -6, -10, which is -16. Okay, that's row 1 complete. Okay, since that row is finished, I am done using row 1 over there. Now we can drop down to row 2 and start using this set of numbers, -1, 3. And I'm going to pair row 2 with column 1. Look for this spot right here. Okay, so row 2, column 1, the first numbers are going to multiply together. So -1 and 4. And now the second numbers are going to multiply together, which is 3 and 6. So evaluate that to be -4 and 18, which is 14. And now finally, we're going to finish this with row 2 and column 2, which certainly means that column is done. So row 2, column 2, I'm going to take -1 and -3, I'm going to multiply those together. And then I'm going to take +3 and -2. Multiply those together. So I'm going to have 3 plus -6, which is -3. And that completes my product. So you can see this is a little bit of work. This is pretty beefy in the amount of work that we have to do. You know, all of this down here is scratch work. It's not difficult scratch work because all it is multiplying and adding, but it's a lot of it, and you have to know what the pattern is as far as going across the rows and down the columns. I think with a lot of practice, this may be something that you're able to do mentally and kind of skip writing all this out, but certainly as you're learning this, I would in no way suggest skipping writing out all this work. I would put it all down and kind of scratch work and keep your solution clean up here. Okay, let's look at another example. Okay, another matrix product to do. First thing you're going to do is check the size of the matrices. So this matrix has 2 rows and 3 columns. So this is a 2 by 3. This matrix has 3 rows and 1 column. And again, what you're checking is these inner dimensions, and you want them to be the same. And if they are the same, you can get rid of them. And what's left over tells you what the size of your answer is going to be. So my solution matrix needs to be a matrix that has 2 rows and 1 column. So let's set that up. 2 rows and 1 column. So I'm going to have a row 1, row 2, and just a single column there. All right, now for kind of the setup and the work. Over here, I'm going to use rows. Always use rows on the left side. So I like to either highlight them like I'm doing here in the notes for you, or I like to maybe just circle them. I think circling them is fine as well. And then in this matrix, I'm going to use the column. This just reminds me when I'm doing the work, kind of what sets of numbers I'm pairing together in my work. So again, here we're using rows, and here we're using columns. So if I want to find the first number, which goes right here on the top, I'm going to use row 1 and column 1. Here's my scratch work. So now this is a little different than the last example just because there's more numbers in the row. But to counterbalance that, there are also more numbers in the column, so we're going to be okay. I'm going to take the first number of the row and the first number of the column. I'm going to multiply those together. I'm going to take the second number of the row and the second number of the column. I'm going to multiply those together. I'm going to take the third number of the row and the third number of the column. I'm going to multiply those together. So I've got now 8 plus negative 27 plus negative 8, which is negative 27 for my top number, or my top entry. Okay, now we're going to jump down to the second row and pair it with the first column, the only column. So I'm going to look at row 2, column 1. And so it's first number times first number. Then it is second number times second number. And then it is third number times third number. Now we're just going to multiply all these and add. So I've got 12 plus 6 plus 2, which is 20. That completes the product. Went a little bit faster this time. There were less numbers to find. But also as you get the hang of this, as you start to understand the pattern, you are going to be able to go just a little bit quicker. Okay, here we go again, another product. Let's first check the size. We have a 2 by 2 matrix. We're multiplying. This matrix has 2 rows and 1, 2, 3, 4 columns. It's a 2 by 4. So we're checking the inside, and sure enough, those inner dimensions match. So our answer is going to be 2 by 4. It's going to be the same size as this one. 2 rows, 4 columns. Let me set that up so I know how big to write this. There's column 1. There's column 2. There's column 3. Column 4. Close out my matrix behind that. And we're going to have 2 rows. Okay? Now I'm going to go ahead and label up my matrices that I'm going to work with. Here is row 1 and row 2. Column 1, 2, 3, and 4. And if you like the highlighting that I've been doing, by all means, go ahead and do that if it's easier to keep them straight, or circle them. I think circling them is fine to do too, but I like some sort of visual indicator that I'm working columns here, and on the left, we are using rows. Okay? I think it's easy to get lost in what you're doing if you don't put some of that kind of setup here down on paper. All right, here we go. I'm going to start right here at the top, row 1, column 1. I'm going to skip a little bit of the writing down the work right here, just because we've done a couple examples already. So I'm gonna do a little bit of this on the fly. So I'm doing first number times first number. That's negative 21 plus, and then go across and go down to get the second numbers. 6 and 3 is 18. Negative 21 and 18 is negative 3. Okay, now I'm going to do row 1, column 2. So I'm just going to do all the top row first. Now I'm going to do the second column. Negative 7 times 0 is 0. Go across and down. 6 times 2 is 12. 0 plus 12 is 12. Okay, next I'm going to stay in row 1. I'm going to jump over to column 3. So negative 7 times 5 is negative 35. And then go across and down. 6 times 0 is 0. Those add to be negative 35. And then finally, row 1, column 4. I'm going to go negative 7 and negative 8, which is 56. And then go across and down. 6 and 4 is 24. Those are going to add to 80. Okay, there's completed row 1. Now I'm going to jump down to row 2. I'm going to do row 2, column 1, row 2, column 2. Just want to get them all. Okay, so we're done with row 1. Let's just get rid of those numbers. Now we're going to go on to the bottom with all of the columns in turn. So 4 and 3 multiply to be 12. And then go across and down. 2 and 3 is 6, 12 and 6 are 18. Column 1 is complete. We don't need that anymore. Next, I'm going to do column 2. 4 and 0, 0. And 2 and 2 multiply to be 4. Those are going to add to 4. That completes column 2, so we're done with that one. Next, row 2, column 3. So I got 4 and 5 multiply to be 20. And then 2 and 0 are 0. 20 plus 0 is 20. And column 3 is done. And then we'll finish this with row 2, column 4. 4 and negative 8 are negative 32. And then 2 and 4 are 8. Those are going to add to be negative 24. Column 4 is done. Row 2 is done. Everything is scribbled out. We have got a finished product. Okay, another example. Find the product if possible. So here we go again. First thing we're doing is we're checking the size. This matrix is 2 rows, 2 columns. We got a 2 by 2 matrix. This matrix here is 3 rows and 3 columns. Okay, so we check our inner dimensions. Remember, they must match. If they don't match, if they're different, then you cannot do this. This is not possible. Okay? Why is it not possible, you might ask, right? If let's just say we started working this problem out, right? Let's say we didn't check the size and we're doing rows over here, and we're doing columns over here. And let's just say we began the first row and column, right? So let's say we're just working this out. We're blindly going, right? So I'm doing row 1, column 1. I would start out with the first number times the first number, which is 28. And then I would go across and I would go down. Second number times the second number is negative 6. And then I would go across and down. But there's no number right here. I don't have a number to multiply the 4. So it's because we don't have the same number of entries going across, right here, as we do coming down here. That's why we can't do this product. That's why these must match. Okay, so don't do the math, just check the size, and if they're not the same, know that you can't do the problem. Okay, this last slide on the video, I think it'd be great time for you to dive in and try one of these on your own. And we're gonna kind of go somewhere with this particular slide at the end. I would like you to try and pause this and then do both of these problems. So you've got this product right here to do, and you've got this product right here to do. Notice that these are the same two matrices. These two matrices are the same two matrices as they are down here. I just switched the order, okay? I'd like you to try them both just so you see what happens. And when you're ready to check your answers, go ahead and press play. Okay, so what did you find? If you worked through it and you got these answers, what you found is that the answers are different. In other words, matrix A times matrix B is not the same as matrix B times matrix A. Okay, that's an important property. Matrix multiplication is not commutative. Okay, commutative property of multiplication is the one that says like 2 times 3, which is 6, is the same as 3 times 2, it's still 6. But with matrices, it is not the same. And the reason why it is not the same is because of how you're using the matrices, right? Like this matrix here, when it was on the left, we used its rows. The same exact matrix when it was here in this position, we used its columns. So we're using the same matrices, but we're using the numbers differently. And because of that, these are not going to work out to be the same matrix products. Okay? So that's the end of this video. I hope you found it helpful. If you did, I would encourage you to support the channel by giving the video a thumbs up. If you have any comments or questions, please drop them down in the comment section below. I really appreciate you watching this all the way to the end to get all this good information at the end of the video. And I look forward to seeing you in the next one.